Okay, we're back online. Sorry, the first thing was just me walking around checking homework. I figured that would be kind of boring. So hi everybody at home again. And here are the answers from number 4, D as in Douglas. Donut, whatever I use one. Page 130, 131. And let's see what we've got. Number 1, red writing utensil, is it ready? Number 1 should be an answer of 32. Number 3 is 7. Number 5 is 11. Number 7 is, I'll accept 2 answers, 13 over 9, or if you like mixed numbers, 1 and 4 ninths. Number 9 is 26 over 31. Number 11 is 3. Number 13 is 32. Number 15 is 3. 17, we start getting formulas. 3r plus 11. Number 19 is k squared plus k plus 1. Number 21, 3s plus 3t plus 11. Number 23, this is kind of big, well, it's 3 terms. 9x squared plus 69x plus 133. That is again, 9x squared plus 69x plus 133. And number 25 is 9x plus 44. Yeah. 25 was 9x plus 44.
11.
11. It's 3. Any others? Yeah.
Number 9 again.
Second?
9.
9. 26 over 31. Any other repeats? All righty. Questions? Yeah. 23. G of f of x. Now we need to, let me just double check this. People listening at home, I'm just going off screen for a second to, oh good, you can see what I'm doing. So g of f of x depends on the 2 functions. F was 3x plus 11. And g of x was something else. X squared plus x plus 1. So g of f of x, question, what are they plugging in? What's the input? What are they plugging into this thing? Yeah.
F of x.
F of x. This is what's got crammed into the input slot. What does G do to its inputs? It does 3 things. Sam, whenever you plug a number in, what's the first thing it does to it?
Squares it.
Squares it, then what?
Adds itself.
Adds that's the way to put it. Adds itself and then
Adds 1.
adds 1. Do that. So it's something squared plus something plus 1. What should I put here? What are you plugging in again?
F of x.
F of x. Do that. Does that make sense? It's the function squared plus the function plus 1. Now let's simplify it. Keep going, Sam. What's f of x in the first place?
3x plus 11.
Yeah, 3x plus 11, parentheses squared, plus
3x plus 11.
yeah, another 3x plus 11. And plus 1. Liz, take this one over. How do you do this?
No, binomial squared.
Yeah, binomial squared. Go for it.
9x squared.
Good.
Plus.
So 3x times 11 is
Oh, yeah, so
33x. Double.
33.
66x, and then plus what?
121.
121. Good. And then this one doesn't change. Can somebody gather up the like terms for me? Good. Some of them don't have like terms.
Wait, 9. And then 69.
Good. 69x plus 9. Oh, great. I just stole his chair. I give you your chair back. Awkward. Oh, we have an extra desk back in there. Yeah, I'm just gonna steal this one for you. People who, ta-da. I know, Rob. To make doubly sure. People listening at home, consider this a commercial break. Okay, so 69x plus. Alrighty, tune in back. Last turn. Good.
Me?
Yeah,
133.
133, exactly. That's the balance. Does that make sense? Any other ones you want to see? Yeah. 7, yeah. 7 is G of 1/3. Now, they wanted a common denominator when you're all done. What they did was 1/3 squared plus 1/3 plus 1. Does that make sense, Bart? They plugged in the 1/3. Then you just do it. 1/9 plus 1/3 plus 1. In order to add these, you need a common denominator. And I think 9 is big enough for all three of them. This is 1/9, this is 3/9, this is 9, 9, 10, 11, 12, so it should be 13 over 9. I kind of like that one, but if you really love mixed numbers, 1 and 4/9. Or if you're addicted to decimals, it's 1.4 repeat. And there are also 12 step groups for that. So I understand. Next. Anything else? I can just start a picture. My name's Brian, and I'm addicted to decimals. Hi, Brian.
I've been sober for 1 week.
I've abstained from decimals for 2 weeks. That's great. I'm sorry, I had a slip today. I put a decimal after him. I'm sorry. Anyway, there's hope. So, moving on. This is being recorded, isn't it? I'm doomed.
Well, they can't see you. Decimals or not.
Yeah, that's true.
They can't see you, they can hear you.
They can just hear me. That's probably enough. Any other questions? Yeah. Never mind. So if you have a new person up there teaching on Monday, you'll know what happened. All right. Go ahead and put that away then. Take out your notes. Now, this chapter is sort of what they might call a potpourri. It's a mixture of stuff. Not potpourri in the sense of like smelling like it, but there's a lot of different stuff, different things in this chapter. And let me show you. Just for example, 2x plus 5y is equal to, and then 3x minus 2y equals negative 17. I'd like you to solve using any method you like. Before you actually do, can somebody name the methods, the possible methods? Let me write it down. Possible methods for solving a system of equations. Yeah, give me one.
Just one.
Go, bring as many as you want.
Okay. Elimination.
Say again? Elimination.
Elimination.
Okay, hold on a second. Elimination. Okay.
Graphing.
Graphing. Hang on a second. One of the world's slowest writers. Graphing, and then what?
Substitution.
Substitution. Okay.
Matrices or Kramer's rule.
Yeah. What kind of matrices?
Inverse matrices.
Inverse matrices. Matrices. And last but not least, Kramer's rule. I will kind of give you a spoiler. There is one other method we're gonna be covering. Not today, I don't think. It's gonna be sometime next week. But, it'll be, exciting. For now, pick a method. Who's feeling brave on this one? And I do not have my heart set on any particular method. You can use whichever method you like. I'm not gonna be crushed if you choose elimination or something. They didn't choose Kramer's rule. It's okay, you don't have to choose Kramer's rule. You do have to do it at least once on the test, but that's about it. So, Becca, start us off. What method would you like best? Elimination, I was kind of expecting that. So, which letters do you want to cancel, the X's or the Y's? Yeah, the Y's seem reasonable. Are they going to cancel right now? No. You need a little boost. As a matter of fact, both rows here. What number would be big enough to handle 5 and 2 at the same time? Like, what would I have to magnify them both up to get them to fight evenly? Well, it's sort of like, if this had been a +5 -5, it would have been beautiful, they'd cancel. But they're not doing that yet. I can do anything as long as I do it to both sides, I can do anything at 1. So if you can multiply this by something and this by something else, you can get them up to the same number. Like what? 10, sounds great. Under here, put plus or minus 10y, just as a reminder. That kind of make sense? Somebody take over. How do you do this? Yeah.
So we would multiply the top one by 2?
Top one by 2, and the bottom one by what? 5. Do you have to multiply by a negative on either one, or no? No, there's already one positive, one negative. They're already fighting. Go ahead and do the top one for me.
So it'd be 4x plus 10y
Okay.
equals -10.
Equals -10, and do the bottom.
That'd be 15x minus 10y equals,
Yeah, sorry about that.
uh,
I do 10 times 5 and 7 times 5, put them together.
85?
Yeah. What kind?
Negative.
So -85. Courtney, take over.
We're gonna add them together.
Okay? What happens?
We're gonna get 19x.
Okay,
That's
Good.
the times cancel.
good. Equals,
-95.
good, -95. 2 negatives add up to be a bigger negative. Does that go in evenly?
No.
I mean, divide by 19.
I don't think that.
Darn this lack of facial expressions. So, go ahead.
-4, or -5, excuse me, that's what I meant to say.
It does go in evenly. -5. So what do you do with that -5?
You plug
Spencer,
that
take
in?
over.
No.
Sorry. Go for it.
Oh, it's me now?
It is.
You plug it into one of the equipment.
Yeah, pick your favorite. You notice there are 4 of them? You can use whichever one you want. I recommend a smaller one because it's not as much of a pain. The top left? Sure. So, go for it.
You can do 2 parentheses -5
Yep.
plus 5y equals -10.
All right. What is 2 parentheses -5? -10 plus 5y equals -5. Keep going.
You divide,
Good
add
save.
10 to each side.
You add 10 to each side because that's farthest away. What do you get?
You get 5y equals
5. Merry Christmas, by the way. And then,
you divide by 5.
what do you get?
Y
Y equals 1. Ta-da. You're done. Does that make sense? Any of the 5 methods, force of habit, sorry. Been doing that first year algebra. Any of the 5 methods for solving systems should have worked. Some of them are more gross than others. I would not use graphing on this one personally, because trying to find the exact answer is ew. Elimination is very nice. Substitution, it works, but you have to get a letter by itself, which I think you can see would be a pain. Because you'd have to get like, add 2y to this side and divide everything by 3. You'd have fractions everywhere, which are not evil, but they can be annoying. Inverse matrices would work. I would recommend that that's kind of a last resort. And Kramer's rule is usually pretty slick in all cases, but elimination is usually pretty slick in all cases too. Everybody steroids so far? I mainly wanted to review elimination because I'm about to put it on steroids. By the way, don't do this in real life. Steroids are bad. There's different types of steroids. There's metabolic steroids and anabolic steroids, and one of them is extremely unhealthy. It's like what muscle builders do to cheat. They inject it into their muscles and they get really huge and then they get sick and die. So don't do it. It's bad. But that's sort of the metaphor I'm using. You know, math equations can take it. Human beings cannot. Try this. Write this down, please. 3x plus 5y minus 2z. You can kind of see where this is going. So, let me see. 38. And then negative 4x plus 3y plus 4z. 2, hang on a second. Negative 30. Better write that down. Your task is to solve this monster. When you're all done, what should you have as a solution? So 3 things. Good.
An answer for x, an answer for y, and an answer for z.
Yeah. We have a solution for x, for y, and for z. Sounds easy, doesn't it? No, it doesn't. It looks horrible. We've got 3 equations and 3 unknowns, 3 variables. How on earth do we do this? We haven't covered this yet. Allow me to show you solving a 3x3 system. This is one possible method. Just for reference, elimination is actually the method I'm going to do here. Could you do graphing? If you're a computer, yes. Believe it or not, we're actually going to touch graphing these things in less than a week. You will be able to graph one of these things by the time you're done with next week. It looks strange. I'll warn you right now. It's actually, no, it's even stranger. You're talking about a parabola?
Yeah.
A parabola is still flat. You can do it on a sheet of paper. What's that?
Is it 3-dimensional?
It's 3-dimensional. Yeah, it's a 3D graph. So we'll figure out how to do that next week. For now, I just tossed that in as a teaser. It's supposed to be exciting, not anxiety-producing. So, substitution would work if you get a letter by itself, which isn't all that hard. Inverse matrices, yeah, we'll talk later. Kramer's rule actually does work here. The disadvantage is you'd have to do, you remember those 3x3 determinants we did last week?
Yeah.
You would have to do that 3 times. Actually 4 times. One for A, one for A sub x, one for A sub y, and new to the stage, once for A sub z. You'd have to get 4 3x3 matrices and make fractions. A sub x over A sub y over A sub z over A. And if you remember how long it took to do a 3x3 matrix determinant, this takes a while. I would not, this is one time I would not really recommend Kramer's rule, although it does work. If you get stuck, feel free. Yeah?
Are we gonna have to do that on the test? Fair roll with the three?
With a 3x3?
Yeah.
No, you will not. That would make an awesome extra credit question, by the way.
Oh my gosh.
We'll see what happens. I haven't quite made up my mind on the extra credit yet. But for now, my recommendation is do substitution. One possible method, substitution. But it's a little weird. You might notice, if you're trying to get 3 things to eliminate, it's really tough. And sometimes it's impossible. Here are the steps you'd like to go through. First, pick any 2 equations. This actually harkens back to something I told you in chapter 1. How many numbers can the human brain handle at a time? Alright? So if I give you a string of 10 numbers to add, how many of them can you add at a time? Two. That's the maximum the brain can handle. There's no such thing as adding 3 numbers at the same time. You can add 3 numbers one at a time quickly. Like 1 plus 2 plus 3 is, oh, 6. What your brain did was 1 plus 2 is 3 plus 3 is 6, very quickly. Or you just saw it in the past and said, aha, I memorized that, 1 plus 2 plus 3 is 6. Well, how about this? 10 plus 11 plus 12.
42. I'm completely dead.
You're very close, with 1 digit off.
I did
32. But how did you do it? 10 plus 11 plus 12. What did you do? You did 10 plus 11 first is 21.
And
Plus 12, yeah. Does that make sense? Or is it 33?
Oh.
Wow. Okay, well that wasn't our shining moment. But the point being, the human brain can only handle 2 things at a time. Look up here. There are 3 equations. We cannot do all 3 at the same time. Cannot. Pick any 2 equations. And here's the important part. Cancel any 1 variable.
Is it step 2 or is it part of step 1?
That's step 1. So there are going to be like 3 steps here for solving 3 by 3. Yeah.
reading substitution or elimination?
Elimination. 1. Wow. Okay. Brain, hand, get talking to each other. Thank you for catching that. That's people watching at home, no, you can't do anything about it. Just erase your own notes. Yeah, elimination. Oops, is oh, I'm gonna put it in the box here. So pick any 2 equations and cancel 1 variable. Step 2. Pick a different pair of equations and cancel, this is important, the same variable as in number 1. As in step 1. That's important. So basically, you're going to take any 2 rows, cancel 1 of the variables. You might have to magnify it, kind of like what we did here, times 2 times 5. You might have to magnify some of the rows to get it to work. Then you start over with 2 new rows. I mean, one of them has to be a duplicate. But let's just say you pick row 1 and 2. The next time you might pick row 1 and 3, or 2 and 3. But you have to cancel the exact same letter both times. So it's to your advantage to pick something that's not too horrendous. Like sometimes it'll be like, oh, these are amazing. It goes up plus z minus z, boom. But then the one down here is really horrible. So use your judgment. 3. Solve the resulting 2 by 2 system. And this is kind of a new phrase, back substitute the 2 solutions to find the third. That is, again, solve the resulting 2 by 2 system. I'll show you what that means after we do it. And then back substitute. Back substitute is kind of like, you know how you solved and you got x? You plugged it back in. That's called back substitution. It's nothing cosmic. It's just a nickname for what we were already doing. So if you already have one of the 2 letters, plug it back in. That's what back substitution means. Let's try this puppy. Who's feeling brave? What I'm going to do, by the way, I'm going to nickname these row A, row B, row row C, just so I can refer to them easily. You don't have to do this on paper, but I will show you a code for doing this that makes this a little more organized and neat and efficient by using the letters A, B, and C. Would anybody like to recommend a pair of rows where they think one of the variables would cancel relatively easily? Yeah.
A and B,
Andy? Okay. Which letter are you aiming for?
C,
Z, you said?
Z.
Okay, Z. Would it cancel right now?
and no,
Which one needs a boost?
B,
What are you gonna have to do to B to get it big enough?
multiply by 2.
Does everybody see that? In order to cancel the Z's in the first two rows, this would have to be 2 times bigger. Here's what I'd like you to write over here. A plus 2B. That's code for take row A and just copy it. 3x plus 5y minus 2z equals 38. And then this is code for take B and B row and multiply by 2. So this would be 4x minus 2y plus 2z is equal to 18. Everybody okay so far? Do it. Let me see. Megan, take over.
So 7x
Okay, 7x.
plus 3y,
Okay. What happens here?
it cancels,
The cancel equals what?
56.
Good. Do you notice the row we have, I didn't solve, I didn't get x by itself, that would have been beautiful, but it's at least smaller. I was starting with 3 variables and now it's down to 2. I'm going to affectionately call this row D. You don't have to again, but I just want to keep track of the rows. So A, B, and C are 3 variable equations. Row D is our first 2 variable equation. You have just solved, or you've just done step 1. So, Katie, take step 2. Can you find a different pair of rows, but if you can cancel the exact same letter? In other words, cancel Z again. B and C, okay. Would they cancel right now? If I added them right now? No, so what would you have to modify? Yeah, the top has to be 4 times bigger, and you have to make it negative, otherwise they won't even fight. Here's the code. Actually, can you guess the code? What are you gonna do with B? Multiply it by what again? Here's the code. Negative 4B plus, and then C, I don't think you changed, plus C. Does that make sense? Everybody kind of recognizing how the code works? So negative 4B, go ahead, okay, tell me what negative 4B actually is.
2x minus y.
Except multiply by negative 4. So just multiply this entire row by negative 4.
Negative 8.
Yep.
X
Negative 8x
plus y.
plus, I'm sorry,
Plus 4y.
4y, good,
Minus 4z.
minus 4z equals,
Negative 36.
good. Does that make sense? We're multiplying this by negative 4 to match up with this. I'm just going to recopy C then. So negative 4x plus 3y plus 4z equals negative 30. Go ahead, Katie, do that for me. You're waiting.
Negative 12x plus 7y.
Okay, cancel, equals
Negative 66.
negative 66. And if you'll notice, that's another equation with 2 letters. I'm going to call that row E. Are you still with me? Again, you could have picked different rows, you could have picked a different letter to cancel. And some people would say like, okay, which one is the fastest? God only knows. This is really, like, are we going to end up with nice numbers or not nice numbers? It's really, really hard to tell. You usually can't find out until you actually hit them. But do you notice I have 2 equations with only 2 variables? Watch what happens if I write them on top of each other. 7x plus 3y equals 56, and negative 12x plus 7y equals negative 66. solve that? And I apologize ahead of time for the big numbers. Would you recommend canceling the X's or the Y's? Neither one of them are beautiful. But, opinion? Yeah.
Why?
Want to do the Y's? Yeah, that looks like if you could buy with a smaller number. What number would be big enough to hold the 3 and the 7 at the same time?
7 and 3.
Yeah, so like what
21,
number?
21.
I'm sorry?
21.
21, okay. I'd like to magnify these up to plus or minus 21y. So I need them both up to 21 and I need one of them negative. I don't really care which one is negative, as long as it's not both. Josh, take over. How do I get this, what do I do at the top?
Oh, you would multiply by 7
Yeah, how about the bottom?
by -3.
Good, by -3. There's no reason you couldn't multiply the top by -7 and the bottom by +3. That will work too, as long as one of them becomes negative and the other one stays put. So Josh, tell me the new top row.
So it'd be 49x
Uh-huh.
plus 21y.
Okay, equals, and yeah, I apologize ahead of time. I do 7 times 50 and 7 times 7. What is 7 times 50?
That'd be 350.
350. Somebody remember 350. And then 7 times 6?
42.
What's 350 and 42?
Oh, 392.
Yeah, 392. Bottom one, take over Austin.
We have, 30, yeah, -36.
Oh, wait, just a second.
Oh, wait, oh, sorry, 36.
Yeah, so 36 x plus
Mhm.
what?
Uh,
Oh, sorry,
mm, plus,
you can do plus negative if you want.
plus -21y,
Sure, plus -21y.
and equals, 198.
A little too big. I did 6 times 30, or, what am I saying? 3 times 60 and 3 times 6. Oh yeah, oh wait a minute, you're right. I'm not done. No, I just need a nap. Well, maybe on both. But anyway, whatever, 198? Okay. Go ahead and keep going. What happens here?
Then you would add them.
Add them together? Anything interesting happen?
You'd have 85x, and the y's would cancel.
Okay.
And then you would get, 560.
Let me see, 500 and, yes, well, let me see, 392, 592, I think it's 590.
Or was it 590?
Okay, fun mental math, people. Does that go in evenly? Okay. I'll give you a hint. If it does go in evenly, 85 times something is 590. What's a real rough guess? Pretend this is 80. It's not, obviously, but he's losing his mind. No, just pretend it's 80 for estimation's sake. What's 80 times 5? Yeah, 400. That's kind of in the ballpark. What's 80 times 6? Yeah,
460.
close. 4.
Oh, 480.
480, yeah. That's in the ballpark. Do you see that? It might be a 5 or a 6 or a 7 or something like that. It ends in a 5. If I multiply this by 5, what's the ending digit going to be? You don't, by the way, you do not have to do this. This is like a little trick. 85 times something with 85 times 5. I don't know if you've even thought about this before. What's the last digit have to be? Yeah, it has to be a 5. It's blah, 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 5. Does that make sense? Because 5 times 5 is 25, and that'll be the last digit. That can't be, because it ends in a 0. Does that help? Give me another number that might work. Yeah. 8, maybe. Let's try it. 85 times 8. 8 times 5 is 40, carry the 1. 64, 68. Ah. Too big, but nice try. Another one?
6.
Try 6. 85 times 6. I hope I didn't do my math wrong. That would really stink right about now. 30, 48, 51. Oh, for the love of all that's holy. No! No. I did, no. No. Those of you listening at home, I just pounded my head against the podium because I think I wrote the wrong number and made this stupid. Hang on a second. Oh, hold on. Let me just double check. I want to do this. Okay, the first row is right. I found it. Let me double check, make sure I didn't do anything down on the third one. Three. Welcome to my life. That's good. Here's what was wrong. Stupid number. Alright, do it. I apologize to your eraser ahead of time. I will do the work for you. You don't need to do the groundwork. But A and B, yeah, this is going to be 38. And this will become, so this changed, and this will be 76. Those are new. Everything else is the same.
Wait, what?
These changed. I just fixed this to 19 instead of 9. And then B and C, just my luck, times 4, negative 76, I think. And this would be negative 106. I think. I just want to make sure that 19 times, yeah, I think it's 76. All right, now over here, let's put a repair here. This is 76. Yeah. I apologize ahead of time. This is annoying. This is a negative 106. Now there's a little bit of good news here. Not much, but a little. Part of the good news is that I'll do the multiplying for you. 76 times 7 is 490 plus 42, 532. Then this is 318. So this is different. This is different. And this should be different. 800 and, oh wow! You want to talk about a nicer, nicer problem? I was wondering why it was so horrible. That's I did a dupus step in the beginning, but I just undupus the side myself there. So, okay, so, Katie, take over. Sweep up the damage. Yeah, what do you get? X equals 10. That's what I planned in the first place. The reason, now that I repaired the damage, yeah, by the way, the test question is not going to be horrendous. It will come out as whole numbers. Though, actually, the worst I will do is maybe I'll put a 1/2 in there or something like that. If you get an answer like, 318 over 13 or something like that, that means either I put a typo in the test, and I'm pretty sure I didn't because I double and triple checked that, or there's an arithmetic mistake somewhere. Now, math people, what do I do with that x equals 10? Yeah. Plug it in. Plug it in where? That's a good question. I got it from here. Now, there are several places I could plug it in. I could plug it in one of the 2 small equations, or I could plug it in one of the 3 big equations. Which one would be useful? Why do you say small? I agree. Definitely, it's easier. Look what happens if I plug in x equals 10. This is 20 minus y plus z. I've still got 2 letters left, so I can't solve. On the other hand, let's just say I do it here. Go ahead and do that. Just plug it in on the top one. Good. Keep going. 70. Okay. No way. y equals 2. You notice we now have x and we now have y. What do we do with these? What do we not have yet?
Z.
We do not have z yet. So, Rainey, take over. We've got x is 10, y is 2. How do you recommend we get z? Can I plug them back into one of these two? Would it help? No, for one simple reason. There's no z. On the other hand, yeah, take your pick of whichever one you want. B, sounds good. Take B and plug in the 2 letters that you already have. Go ahead and do it.
The 2 from C to 10,
Okay?
plus negative,
Yeah, plus negative. That's right. 2
plus Z,
plus z is equal to
9,
19. Do some simplifying. So
Yeah.
20 plus negative 2 plus z is equal to 19. What's this?
18,
18 plus z is equal to 19.
subtract 18.
Exactly. What do you get?
1.
And congratulations, you're done. That's how to solve a 3x3 system using elimination. Pick 2 rows and eliminate something. Then pick 2 new rows and eliminate the exact same something. That'll give you 2 smaller equations that hopefully you can solve without too much pain. Once you do that, you'll have 2 letters, back substitute them in order to get the third and final letter. And do that. Questions? All right. We're looking at number 4E as an effort, and I'm not going to give you the whole thing. Where is it? I'm actually going to skip 4E for now. I'm going to go forward and do, oh my word. Okay, got it. This is 4.6, we're looking at page 141-ish. 4F as in Frankfurter. And I had assigned for 4F 1, 5, 9, and 15. I'm going to change that. For Monday, I just want you to do 1 and 5.
So 2 problems.
2 problems. 2 problems like that, so it'll more than keep you occupied. Now, these, I'll tell you right now, 1 and 5, number 1 should have all round numbers. I will tell you number 5 has a single fraction, and it's a fairly friendly fraction. So number 1, you should get all integers. Number 5, you should have 2 integers and 1 fraction for your solutions. Just warning you out of that. Questions? The rest of the hour is yours. Go ahead and pound away at it. Yes.
Do you want me to?
Oh yeah, please. Bye everybody. Thanks for viewing. Click subscribe and like.